Okay, so we're finishing up chapter 8 and using our balanced equations and our understanding of molar masses and stoichiometry to be able to figure out very practical things. Like if I have a certain amount of one reactant, how much of the other reactant would I need to use it all up, okay? So we talked about limiting reactants. So if I have a lot more of one than the other on a molar basis in terms of what's needed for reaction, which one is going to limit how much product I can make, okay? So the last thing that we're going to talk about in terms of reaction stoichiometry, okay, is going to be this concept that we call theoretical yield and percent yield, okay? So if we go back to our example of the cars and the steering wheels and the tires, okay, the limiting reactant, okay, is going to determine how many cars I can make, okay? And the amount of the number of cars, the number of product that we can make based on the amount of limiting reactant we have is called the theoretical yield, okay? So if if every one of those tires, okay, wound up in making a car, I'd be able to make 50 cars, okay? Now, let's say, okay, that, something happened, my factory's on a hill, and, 8 cars or 8 wheels rolled down the hill, and I wasn't able to use them to make cars. I don't know. All right, let's say, in that case, our actual yield, okay, would be 2 cars less. So that would be 48 cars, okay? And so what we call percent yield, okay, is the relationship between how much material I was actually able to collect at the end of my product, okay, which would be my 48 cars, divided by how much could have been made given the starting material I had, okay, which is 50 cars. All right, and then we put that in percent. So, we could leave it as just the ratio, or we could put it in a number that has more meaning for us as humans. Okay, and so in this case, my yield was 96%. So we can do the same thing, okay, in a chemical context. So what we're going to do is we're going to revisit, okay, the alum lab, which is where you took aluminum foil, okay, and you converted it into that kind of fluffy white solid that gets used in everything from culinary to fabric dyeing applications to water purification, okay, so a useful product made out of aluminum metal. So let's skip forward to that. And so what we're going to do, okay, is we're going to calculate a percent yield just like you did in lab, okay? So, and we're going to do this as a group, not as a team challenge today, okay? All right, so we're going to start with less than a gram of aluminum, and we're going to make that much alum, okay? And we're going to figure out what the percent yield is, okay? So a couple of things, okay? In this case, okay, you're only told, how much aluminum you started with, okay? And when you did this in lab, you took a certain amount of aluminum and, we kind of told you that all the other reactants were in excess, okay? So the potassium sulfate, the water. So this is going to be our limiting reactant, okay? So at this point, we're going to kind of skip the step where we have to figure out which is the limiting reactant, right? So we're starting with aluminum, and we're going to make potassium aluminum sulfate dodecahydrate. We have our molar masses, okay? And we have our stoichiometry from this equation, okay? All right, so the first thing we have to do is figure out our theoretical yield. Which, you know what, where is, all right, and so our reaction stoichiometry, okay, is going to tell us that this is kind of the overall end one. There were a few steps before it, but we had a 1-to-1 ratio between moles of aluminum and moles of product, okay? So just to, all right. So our theoretical yield in this case, okay, is going to be how many moles of aluminum we started with, okay? And again, we are first converting into the units of moles, right? So we want moles of aluminum. We've got our molar mass right here. So that's going to be 26.98 grams per mole. All right, and that gives us 0.0365 moles of aluminum, okay? Now we have to turn that into grams of product. So first we do the moles of the limiting reactant. Okay. Then we figure out the moles of the product. So we've got 0.365 moles of aluminum. And we have a 1-to-1 ratio, okay, of aluminum atoms to product. Okay. So we've got 1 mole of, and I'm just going to call it the product because the formula is so long, but this is my product, per 1 mole of aluminum, right? So we've got 0.365 moles of the product. Now, if my starting material, the reaction that's up here is a little bit, is the wrong one for me to show you it. I don't know how this one got on here, but if we were using this as a starting material, okay, then it would be 1 mole of that per 2 moles of product, okay? But in the overall reaction, if we showed the previous steps, it would be 1-to-1, okay? And so that would just change this number right here, okay? All right, so now this is what can be made. So let's turn that into the grams of product that can be made, because that's a thing that we can measure in the lab. So we got 0.365 moles of aluminum of product, aluminum potassium aluminum sulfate, times the molar mass, 474.37 grams per mole. Okay, so, oops. And this is 0.0635. Sorry, I had my decimal point in the wrong place. I'm like, that looks like too big of a number. 0.03. And that should have a 0 there. all right, times 474.37. And so that winds up being 17.3 grams of product. That's what we call our theoretical yield, okay? So the final thing we want to do is determine my percent yield, which is going to be equal to the amount that I recovered. Okay, so that's the amount recovered or collected at the end. Okay, so that's my 14.8 grams divided by the amount that I could have made if everything had been efficient and I hadn't, had any crystals sticking on the sides of the flask that I was using. So and then we're going to put that into units of percent. 14.8 divided by 17.3 times 100 gives us 85.5% yield. Okay. So here again, we're using reaction stoichiometry, excuse me, to tell us the ratio of molecules of objects, okay? When I'm starting with a certain number of reactant objects, how many product objects can I get, okay? And if that certain amount of reactant objects weighs a certain amount and my product weighs a certain amount, okay, I can use conversions to the unit of a mole to put things kind of on the same, on the molecule per molecule or object per object basis. All right. So that's the end of chapter 8. What I'm going to do